right, so today we're going to look at solving trig equations analytically, which means algebraically. Most trig equations, if you just made one up, could be pretty difficult to solve by hand. So all the ones we solve today have to work out special. Either they're going to factor, we can use quadratic formula, things cancel. They all have to work out nice in some way. Okay? So the identities we'll be using, some Pythagorean identities, double angle identities, maybe some of the basic ones like sine over cosine equals tangent, stuff like that. But we'll go through and see what happens. Okay, some different techniques we can use to solve identities. Okay, factoring. Try writing a problem that has multiple trig functions just in terms of one. Okay, like so try to make the whole problem have sines in it or cosines, but not a mixture of different ones. And we can also use the quadratic formula. Okay, so the trick about using quadratic formula, I think we looked at that yesterday. Anytime you have a problem where you've got in this form something squared plus the something and then plus a constant. Okay, that's a quadratic type equation. Okay, whatever's in the boxes, that's what you're solving for. So if you had something like x squared plus 3x plus 2 equals 0, and you use quadratic formula, you're solving for this variable that's in the middle box. You're solving for x. Okay, if I had something like, say, sine, and a plus 2, what would I be solving for this time? I'd be solving for sine x. Okay? So my very last step would be to get rid of sine x with inverse sine. Okay? So anything of that form is a quadratic type equation. Something squared, just the something, and then a number at the end. All right, so this is asking me to find all solutions in one period. Okay, so first thing, we shouldn't be putting plus 2 pi k on the end of any answer, because they just said between 0 and 2 pi. Okay, the second thing is this almost looks like a quadratic type equation, but how come it's not? Something wrong with it, and we're going to try to substitute that. Yep.
Because you have two different trig functions.
Right, we've got two different trig functions. Okay, we've got cosine and we've got sine. So what I would do first is substitute for this. Okay, using our Pythagorean identity. Okay, what does cosine squared equal? Yep. Yeah, 1 minus sine squared. Okay, so plug that in. Okay, and we'll distribute, combine like terms, and then clean this up. Okay, but at least now, we just have one trig function. All right, I'm going to distribute, and I'm going to combine like terms at the same time. So I'm going to get negative 2 sine squared x plus sine x. And what is my constant going to be? Yeah, I'd get 2 times 1 is 2, plus 1 more at the end, plus 3. Now, what type of equation is this? Yeah, it's a quadratic. Okay? So in this case, what's A? Negative 2, B, 1, C, B. Okay, so just go through the quadratic equation really quick and find out what our two solutions come out to. And then keep in mind we're not solving for x. We're solving for sine x.
Where is it? Where did it come from?
Agree? We did 2 times 1 and then plus 1.
Oh, okay.
So we just distributed and combined like terms. All right, so we get negative b plus or minus square root of b squared minus 4 ac all over 2a. Okay, so we're going to get minus a minus becomes a plus. 4 times 2 is 8. 8 times 3 is 24. 24 plus 1. Yeah, so that's nice. So because this is working out nice, we might have been able to factor this. Okay? But if you'd rather not factor, just use quadratic formula, that's fine too. Okay, but this one probably would have factored. Okay, so we get negative 1 plus or minus 5 over 4. So let's write those out. What's negative 1 plus 5? Positive 4 divided by negative 4. Okay, so I'm going to work on solving this in a minute. And what's negative 1 minus 5? It's negative 6. Negative 6 divided by negative 4.
1.5.
Yeah, 1.5. Okay, and now I'll work on solving that in a second. So now they're asking me where sine equals a negative and where sine equals a positive. Okay, there's 2 quadrants where that happens for both. Where would I expect my 2 answers to be for sine of x equals a negative? Which quadrants?
3.
Yeah, 3 and 4. It could end up being right on the axis, in which case if that happens, there'd be only one solution. But generally, the 2 solutions are in quadrants 3 and 4, or you got one right on the axis. Neither quadrant. This one, think about your graph of sine. Where does sine hit negative 1?
3 pi over 2.
Yep. 3 pi over 2. Now, I just have to make sure that that answers between what they said. They said 0 to 2 pi. That is correct. That is between 0 and 2 pi. If you did this on your calculator, it's not going to give you 3 pi over 2. What do you think it would give me if I press inverse and then sine? It's going to do it in degrees, first of all, but it's going to be a nice answer, but it's not going to be 3 pi over 2. This is 270. So that's the answer that I want, but it's not what my calculator would give me. My calculator would give me negative 90. Okay, so remember, inverse sine, the calculator always gives you an answer between negative 90 and positive 90. In this case, they did not want the answer at negative 90. So if you did that on your calculator, what would you have to add? You could add 360 to get it to the next period, or 2 pi if we're doing radians. Okay, so that's that answer. Right. Now think of your graph for this one. Where does sine hit 1.5? It doesn't. Okay. So what that means is this gives us no solution. Okay? So this part results in no solution. That's the only answer to the problem. 3 pi over 2. Okay. Any question why this part is no solution? Okay, so we went from a problem that could have had potentially 4 answers. 2 spots where sine is negative, 2 spots where sine is positive, but sine never gets this high, so we had no solution. And this part was right on the axis, so we only had one solution. Okay. Any question on that? Okay. All right, let's try this one. 2 sine squared x equals 1 plus cosine x. Okay, a couple problems with this. 1, it's not equal to 0. And 2, we don't have all the same trig function. All right. So what should I do first? Yep.
Take the right and put it to the left.
Okay. You can take everything that's on the right and move it to the left. Okay. What should I do next? Brian?
Transfer sine squared x into its other form.
Yeah. What's sine squared x?
Is it cosine squared plus 1? Cosine squared x plus 1? Or is that 1 minus?
1 minus sine squared. Yeah.
1 minus cosine.
Yeah, we're doing it the other way. Sorry. 1 minus the cosine squared. Okay. Minus cosine x. Okay. So when I rewrite that in descending order and combining like terms, can anybody tell me what I will have? That's good.
Minus cosine x plus 1.
That's going to give me 2. Take away 1, plus 1. Okay, any question on that? Right, we could try to factor this one if we wanted and see if it comes out nice. If I'm going to factor it, though, I like the coefficient of x squared to be positive. So how could I change the sign of... Yeah, I could multiply everything by -1 and change this to 2 cosine squared x plus cosine x minus 1 equals 0. That's the same problem. Now I'm going to try to factor this. So I would have 2 cosine. And what would I have here? Cosine x. Now I need a positive middle and a negative constant.
You'd want the negative in the same one as the 2. Or it would be 2 cosine x minus 1.
Okay, let's try that. So we got 2 cosine squared. We're going to get 2 cosine x minus 1 cosine x. That's cosine x. And -1 times 1 is 0. So that one factored perfectly. Okay, any questions on that? Now, once I factor it, what do I do with each factor? Yeah, just like we did with quadratic equations. Set each one, we're going to get an answer from each part. So 2 cosine x is going to equal 1. Cosine x equals -1. Or, any questions on how I did this? So I set this equal to 0 and I moved the 1 at the same time. All right, so now how would I solve for cosine x?
Divide each side by 2.
Yep, divide each side by 2. And now what would I do? This is the step you would have been at with the quadratic formula. Cosine x equals 1/2. Now how do we get just x? Yep, inverse cosine. So take inverse cosine of 1/2. Inverse cosine of 0.5. Okay, if you look at that and you don't recognize it in radians, sometimes what I do is do it in degrees. And then I'll usually get a nice answer. And then I can change to radians if I want. 60 degrees. Okay. What's 60 degrees in radians? Pi over 3. It's a little hard to see that looking at the decimal, I think. So I do it in degrees and then change it. Now, that's a 60 degrees. That's a first quadrant angle. Is there any other quadrant where cosine is positive? Fourth quadrant. Okay. Once you have your reference angle, what do you do to get an angle in the fourth quadrant? 360 or 2 pi minus it. Now, do whatever is quicker for you. If it's quicker in your head to think, all right, that's 360 minus 60. It's 300 degrees. We just need that in radians.
5 pi
5 pi over 3. If pi over 3 is 60, and you multiply 60 by 5, that would give you 300. Right? When I'm done, I'm going to check to make sure these answers fit whatever criteria they asked for. In this case, all solutions within one period. Okay, I'll check that at the end. Okay, second part, cosine x equals -1. Okay, where does that happen?
Yes.
Yeah, 0, 90, 180, 270, 360. So that one happens at pi. Okay, if you use your calculator, it would actually tell you 3.14 or 180. Should. Okay, so this time that would give you the correct answer. Now we just have to make sure that all the answers are within one period. Okay. What's the period of sine squared? Did that last academic week. It was a while ago.
0 to 2 pi.
So period single number. It's not 2 pi. Pi. Okay, the period of sine to an even function is pi. What's the period of cosine? 2 pi. What's the least common multiple between pi and 2 pi? 2 pi. Right? So all the answers here to be within one period have to be within a distance of 2 pi from each other. I would just go 0 to 2 pi as your window. Are all these answers that we have here, pi, 5 pi over 3, and pi over 3, between 0 and 2 pi?
Yes.
Yeah. 6 pi over 3 would be 2 pi. So 5 pi over 3 is less than that. So these are all correct. Any question on that one? All right, let's try. Actually, this part, I just want you to read it. You don't have to write this down. Okay. We've talked before about finding all solutions. Okay. We're not finding all solutions in this section. Okay. I want you to remember that there are infinitely many solutions. Okay. We find one and then we put plus pi k or 2 pi k, or you can use n. But we are not finding all solutions. Okay. We're finding specific solutions. Okay, everyone understand the difference between finding specific and finding all? Okay, so we're not finding all in this section. Okay, find all solutions between 0 and 2 pi. Okay, any thoughts what I should do first here? Right?
You probably want to turn tangent into sine over cosine.
Yes. Yep. Change tangent into sine over cosine. Okay, that's a good first step. Any thoughts where you would go from there? Yep.
Multiply both sides by cosine x.
Yep. Multiply both sides by cosine x. And now it's just turned into a problem like we just did. Okay, make sure, we're going to have to make sure we double check our answers here because we just multiplied both sides by something that has a variable. And it is possible that cosine comes out to 0. So we could have just multiplied both sides by 0. All right, so when we're done this, we'll just double check. And make sure that our answers work. Okay, we can check that graphically, okay, to make sure they work. All right, so we're going to have 3 cosine squared x minus sine x. And what could we change cosine squared to?
3 cosine.
1 minus sine squared.
1 minus sine squared. Okay, so I'm going to plug that in, distribute, and write it in descending order all at once. So I'm going to get negative 3 sine squared x minus sine x plus 3. Yep. Now this time, I'm not going to waste time trying to factor it because this one doesn't factor. Hey, and if you look at the book, they did it slightly different. They had 3 sine squared x plus sine x minus 3. They multiplied everything by negative 1. I'm not going to bother with that. Okay, because we're not going to try factoring. All right, so what's A, B, and C? Okay, fill that in and see what we get. And when we get our answers, what are we solving for? Well, what's our expression we're solving? Like, are we solving for x? We're solving for sine x. Okay, so remember, at the end, we'll need inverse sine. All right, so we get let's see, 1 minus 3. All right, what's that, 37? Because that's going to be 12 times 3 is 36, plus 1 is 37. Okay, and let's see, just to save us time with the decimal, they don't. Okay, now keep in mind, this is equal to sine x. Let's try well, think about this in your head. The square root of 37 is a little bigger than 6. So if you did 1 plus a number that's a little bigger than 6, you'd get a number a little bigger than 7 in the top. Number a little bigger than 7 divided by negative 6. That's going to be a little bigger than negative 1. Does sine ever hit negative 1? No. So you don't have to worry about the case where it's 1 plus square root 37 over negative 6. Okay? You're not going to get any solution from that part because it's going to be negative 1 point something. You can type this all in if you want. Okay? If you get a number past negative 1, it's not going to work. Right? So let's just worry about the minus. Okay, and I'll put a note there. Plus case does not work. Okay, now I think this case, it's going to be fine. If you do that out as a decimal, you get about 1 point. You know what? They don't have it. Let me do it. Is it 1 minus square root 37? Square root 37. Okay, that's the top. Divide by negative 6. We get about 0.847. Okay. Does anyone need me to show that the plus case wouldn't work? Because it's just doesn't work. All right, so we got 0.847. And now I'm going to take the inverse sine of 0.847. Let's use this calculator. And you know what? Let's do it in radians. Most of the time, the book, they'll give their answers in radians. Second inverse sine, 0.847. Okay, 1.847 1.01, and that's what the book says, 1.01. Okay. At the end, I'm going to graph and make sure that that's not extraneous. Okay, just make sure that it really works. What's my other quadrant where sine is positive? 2. And what do I do in quadrant 2 with that angle? Yep. So pi, since we've already rounded, we can round pi because we've already rounded 1.01. So 2.13. If the other case had worked, I'd be getting 2 answers there as well. Right, so now I'll graph it and make sure that by multiplying by cosine, we didn't mess anything up. Just graph it the way it is. Okay, so tangent x, 3 cosine x, and 0 to 2 pi. No. So 0 to 2 pi. I wouldn't worry about the y-axis too much because tangent's going to go up and down forever. Okay, how many times am I hoping these graphs cross?
Twice.
Hopefully twice because we got 2 answers. Okay, so there's tangent. There's 1, 2, and I think we're good. Okay, so those 2 answers, if you did second calc intersect, would be what we just found. Okay, does anybody need me to verify that graphically? No, okay. Just trust me. Okay, any other questions on that one? All right. Does anyone need to try another one like this? This is very similar to the ones we've been doing. Change cosine squared to sine squared and go through it. If you get imaginaries, like if you end up with square root of a negative, then the answer is no solution as you go through the quadratic formula. It is possible that can happen. 2 graphs might not cross. All right, let's see if we can do this one. Okay, I wrote above we'll use a combination of algebra and then the calculator. Well, we'll just see what happens as we go through it. Okay, what's one thing, looking at this right away, you might want to try to do something about? Okay, same kind of problem we've had in the last couple. Yep.
Turn it into either side.
Well, in this case, I would change it either into tangents or secants. Okay, you can use, I would stick with one of the trig functions that's already in the problem, but pick one. Don't use both. You think it would be easier to change everything into tangent or change everything into secants? I would change everything into secants. So we got to get rid of secant. Does anybody remember what secant squared equals?
1 plus tangent squared.
Yep, that's an identity. 1 plus tangent squared. Okay. So we have 1 plus, that just stays the same. Okay, that's one of our Pythagorean identities. 1 plus tangent squared equals secant squared. Yeah. Okay, I'm gonna do that, and I'm gonna bring it to the other side. So I'm gonna do 3 tan to the 4th x, and then I would have 2 plus tangent squared, but I'm gonna minus tangent squared, and minus 2. Is that a quadratic equation? It is, yeah. Anytime instead of just saying squared and, a square here and a first power in the middle, anytime that your first term, the exponent is double the second, and the last term is a constant, it's a quadratic type equation. But what would you be solving for if you use quadratic equation? You'd be solving for tangent squared. Okay, you're solving for whatever's in the middle. Okay, so anytime the first term, its exponent is double the middle, and they're the same function, okay, and the last number is just a constant, it's a quadratic type equation. But this time we don't need quadratic formula. This will factor. Okay, let's see if we can factor. What would my first term have to be?
3 tangents squared x.
Yep, 3 tangent squared x.
Negative
Give myself a little more space. And what about my first term in the second factor? Okay, I have a negative and a negative, so my signs have to be
Positive and
2
negative.
and minus 1.
positive, negative.
Plus 2 minus 1.
All right, let's try it. So we got 3 tangent to the fourth, negative 3 tan squared plus 2. Negative 3 plus 2 is negative 1, and 2 times negative 1 is negative 2. Perfect. Okay, so now we factored it. All right, what do we do with each one of those factors?
Let me go to 0.
Yep, so we get, let's do it like this. Tan squared x would equal negative 2 over 3. Okay, I did the minus 2 and divide by 3. And what about over here?
It just equals 1.
It would equal 1. Okay, any thoughts about that left-hand equation? Tangent squared x equals negative 2/3. Okay, well, think of it this way. It's the same thing. You would. You take the square root of both sides. So any thoughts now?
It's going to be imaginary.
It's what?
Isn't it going to be imaginary?
It would be imaginary. Okay, if you try to take the square root of what's on the left to cancel that exponent, then you're taking the square root of what's on the right. You can't take the square root of negative. You can't square root of negative. Okay, so that's imaginary. We're not interested in imaginary solutions.
So then it says tangent.
So yeah, the only thing we get here is tangent squared x equals 1.
Which is tangent x.
So what does tangent x equal?
1.
Square root of 1.
The square root of 1, which is what?
1. Or 1 or negative
1 or negative 1, both. Okay, so you've got to be careful with that, plus or minus 1. Okay, so how many answers could we potentially get here? More than 2. 4. There could be 2. There's 2 quadrants where tangent equals positive, and there's 2 quadrants where tangent equals a negative. So we could get up to 4 answers, but also keep in mind, we can only go up to pi over 2. If we get an answer higher than that, we ignore it. Okay. So really, the only answers we're looking for are there and there. Negative pi over 2 to pi over 2. I have a feeling these other answers, they're not going to be in the domain that they're looking for. Right, so let's go through it. Let's take inverse tangent of 1. Second, inverse tangent of 1. That's going to give me that's pi over 4. Okay, it's 45 degrees. Okay. If you didn't know that, just do it in degrees. You'll get 45, and then you could change it, and you'd see it's pi over 4. Okay. Is that between negative 90 and 90? Yep. So this answer is good. Where else is tangent equal to a positive? Quadrant
Oh,
3. If we do 180 plus my reference angle, am I going to be between negative 90 and 90? No. So they don't want the other answer. Okay, let's do inverse tangent of negative 1.
Which do negative.
It's just going to be negative 45. Yes. It's negative pi over 4. And now if you go through the same logic, the other quadrant where tangent is negative is quadrant 2. But the problem is quadrant 2 is not between negative 90 and 90. So we have found both the answers they wanted. That's it. Okay, questions on that one? So be careful you don't write more than you need to. Okay? Lots of things to be, just try to keep in mind. What do we have left? Okay, some of these are repeats, but this one is different. Okay? It's a factor by grouping. Okay, so factor by grouping is when you factor out what you can from the first two, factor out what you can from the last two, and then see what happens. All right, what can we factor out from the first two terms? They don't have a lot in common, just one thing.
Cosine.
They have cosine in common, but that's it. If you factor it out of the first term, you're left with
2 cotangent.
2 cotangent. If you factor it out of the second term, you're left with minus 3 plus,
6 cotangent.
what could you factor out here? 3. I think that's it. Okay, if we factor out a 3, what would you be left with for your first term?
2 cotangent.
And if you factor a 3 out of 9? Minus 3. Yeah, now you can factor this expression out, pull it out of both of them. 2 cotangent x minus 3. This is what always happens with factor by grouping. If you pull that out of the first term, what are you left with? Cosine x, yep. And as Maddie just said, if you pull it out of the second term, you're just left with plus 3. Okay, I'm looking at this second factor and already thinking about setting it equal to 0 and deciding it doesn't matter. Why? This part of the problem is not going to do anything for me. Yep.
Because cosine doesn't go over 1 or negative 1.
Right, cosine has to be between 1 and negative 1. If you set that equal to 0, you're going to get cosine x. You can't solve that. Okay? So, there's no solution from that part. So now we're just going to deal with this part. Okay, what would cotangent x equal? 3 over 2 plus 3 divided by 2. All right. Now this, we don't have a button for inverse cotangent. Well, think of it this way. If the cotangent is x, what's the tangent?
2/3.
2/3. Now I have a button for that. Okay. So just flip it, and you can change cotangent to tangent. Right, so let's take inverse tangent of 2/3. Okay, so second inverse tangent, 2/3, 0.59. What other quadrant would I have an answer in? Quadrant 3. How do I get an answer in quadrant 3? Add. pi plus 0.59. It's okay to use 3.14 because you've already rounded the other answer, so the accuracy at this point is already 2 decimal places. 3.73. And we're good. Okay, let's make sure, was there any criteria? Find all solutions in one period. Okay, the period of this, well, I see a cosine, so the minimum the period can be is 2 pi. Okay, everything else is pi, 2 pi, 2 pi, pi. Okay, so the period here is 0 to 2 pi. These answers are between 0 and 6.28. So I'm good. Okay, questions on that one? All right, let's see. That's different, so let's do that one. That's actually the same question. And if we have time for the last one, we'll do it. If not, then that's fine. Okay, now here the problem isn't you have different trig functions. Okay, you've got sine, but what's the problem here? Yeah, your arguments are not the same, so you can't work with that. So we got to use our double angle formula and rewrite it. 2 sine cosine. Okay, what would I do next? We got to be careful dividing by sine, because if we divide by sine, could be 0, and then we just divided by 0. But I want to get 0 involved, but I don't want to accidentally divide by it and not know it. Where? Yeah, let's get this equal to 0. Okay, bring sine x to the other side. Okay, now what would we try? Yeah, factor out sine x. I'm going to be left with 2 cosine. And that's basically it. Now just set each factor equal to 0 and solve. So sine x equals 0. Or, what would cosine x equal? Plus the 1 divided by the 2. Okay, this is possible. Okay, it's not, I can't just cross it out this time. That's probably going to work. Where does sine equal 0? It starts at 0. And at 180. And where cosine hits a half. Okay, if you're not sure, just use your calculator. 1.04, we've seen that angle today.
That's 60.
60, it's pi over 3. I'm looking for where cosine is positive. What's my other answer? Fourth quadrant. I think we did this earlier. 5 pi over 3. Good. And let's see, the book says 0 pi over 3 pi, 5 pi over 3. Yep, we got them all. Good. Okay, so that one actually isn't too bad, even though you had to use a double angle formula. I think we've done ones today that turned out longer than this one. So, hey, questions on that? That's exactly the same problem. All right, we'll try this one and see if we can solve it. Cosine 2x minus 2 sine squared x equals 0. Okay, what's the problem with this? Yeah, and I think we can deal with both of those at the same time. We can probably get rid of the 2 and change this to sine. So let's look up our half angle formula for cosine 2x. Which one of these would get rid of the 2 and give me everything in terms of sine?
1 minus the 7.
Yeah, use that one. Okay, 1 minus 2 sine squared x. Minus 2 sine squared x. I wouldn't factor here. Yeah, combine like terms. Minus 2 sine squared x minus 2 sine squared x. That's minus 4 sine squared x.
Sine squared x has to be equal to 0.2.
Okay, what would I do next? You're on the right track. I just want to see, I want people to see how to get there. Before you divide by 4, minus the 1 and then divide by. Now divide by negative 4, and you were right. It does have to equal 0.25. Okay, but I got to get rid of this exponent of 2.
Then it's 1/2. Again, 1/2.
So what would sine x equal?
1/2.
Careful. Plus or minus 1/2. Okay, when you take the square root of 1/4, one answer is 1/2. The other answer is negative 1/2. Okay. Now we need to solve each one. Take the inverse sine of 1/2. Does anybody know what you're going to get? 30. Okay, if you don't recognize that, that's pi over 6. Do it in degrees first, and then change it to radians. So we get pi over 6. Where is my other solution? Quadrant 2. That's 180 minus 30. That's 150. 5 pi over 6. All right. Sine of x equals negative 1/2. Oops. Yeah, it's just going to be negative 30. Okay, just to show people. Okay, negative pi over 6. I'm going to write that for now. I'm going to check my restrictions in a second. And what's the other quadrant where sine is negative? We just got an answer here. All right. My reference angle here, you always look at that as a positive. So my reference angle is pi over 6. What do I do in quadrant 3? You add 180 or add pi.
pi
7 pi over 6. Okay, and let's see. All right, so now what did they say to give answers between? One period.
Which is 0 and 2 pi.
Yep.
That
So
means the only one that doesn't work is the negative pi over 6.
trying to think, did I do this one? All right, so the book had the pi over 6. They had the 5 pi over 6. They had these two. And then, let's see. Let's look at what the period is, because they said one period. I see the problem. What's the period of cosine? Cosine 2x, sorry. Period of this is pi. What's the period of sine squared? So what's the least common multiple? So we only want answers between 0 and pi. Anything that's not between 0 and pi, we don't want. Pi over 6 is fine. 5 pi over 6, is that between 0 and pi?
No.
That's a repeated answer. That's why we're not listing it.
And it's greater
And
than
that's
pi.
greater than
And that's greater. That's why they don't list them. Okay, so not listed because period is pi. So you only want answers between 0 and pi. Okay, so that was tricky to remember that, but that's important. Okay, questions on that one? All right, so not every problem in the homework is going to be like this. Some problems in the homework, I'm going to start you at that step right there. And all you're going to have to do is work from this step down. Okay? Some problems you'll have to get to this step. But the first 6 questions are all just a trig function equals a number. So most of the work is already done. Okay? And then they kind of build from there. I'll give you some problems that are already in factored form. Okay? So then on some problems, maybe I'll start you at this step, and then you have to do that step. And then some, I'll just start you right from the beginning, and you work all the way through. Okay. All right, so the homework, it's on 423, 1 to 14, 16, and 19. Okay, we'll go over that tomorrow. This finishes up Chapter 7. Okay, tomorrow we'll start Chapter 8. Chapter 8, first section, extremely easy section. We should have time at the end of class to review for the test.